Good morning, girls. Good morning, everyone. So today the lecture topic is morphological model. um, we'll go through this all morphological models. There are 5 morphological models in the NLP. Okay, so first of all, so these are the morphological models we are having: dictionary lookup, finite state morphology, unification based morphology, functional morphology, and morphology induction. Okay, so now we will go for dictionary lookup. So before that, we need to understand what is a morphological models. Okay, so morphological models. So morphological model means it's a kind of a model. This will used to analyze the structure and formation of the words. So by using the morphology procedure, we can analyze the structure and formation of the words. So this model actually, this all morphological models actually helps us to identify the particular morphemes and in the particular sentences, so where that morpheme can be incorporated in the sentences. Okay, and also these morphological models used to understand the morphology of the different languages, different natural languages. Okay, so here the morphological models are dictionary lookup, finite state morphology, unification based morphology, functional morphology, and morphology induction. So these are the 5 morphological models we will use to analyze the structure and formation of the words. Okay, so now we will go for the dictionary lookup. So the dictionary lookup, so dictionary means everyone will remember that in the childhood days, in like 10th class, like that time, everyone will use the dictionary for understanding the words. So the same concept here also we will use. Okay, so dictionary lookup, see the name itself, lookup. So suppose you find a word, so that word you can look up in the dictionary and find the patterns of that word. After finding the patterns of that word, you can retrieve the information whatever you want, like parts of speech and sentence formation and present tense or past tense formation. All these things you can retrieve from the dictionary. So the same procedure here we will use. Okay, so here dictionary lookup, this is also one of the morphological model. Obviously this morphological model is used to analyze a particular structure of the word. So all morphological models are used to analyze the structure of and formation of the words only. Okay, the procedure is different. So now coming to the procedure of dictionary lookup. So how the process will happen for analyzing the word in the dictionary lookup model is, suppose you consider a simple example here. So you can consider any example, but here I used beautiful. Okay, so the beautiful is a one word. So how we will form this word, how we will retrieve the information based on this word. Okay, so first we can convert the chosen word, the chosen input word, into the canonical form or base form. That means we need to find the root word of the given word, given token. So you can simply say that a token. So from the token you need to find out, the base form or canonical form of the word. So after identifying, see here a simple example we chosen, right? First token is beautiful. So the token is beautiful. So from this token we find the root word, that is a base form of this beautiful. So what is the base form of this beautiful? Beauty, B-E-A-U-T-Y, or T-Y. Okay, so this is the canonical form, root word of the beautiful. So after identifying the base word, what we need to do? We need to search in the dictionary, so our corpus. So normally in the NLTK library we are having a corpus. It's just like a database. So in this corpus all English words will be available. So there we need to search the base form of the given token or given word. So here we need to see the three important things, not three important things. So if you find the base word exactly, okay, so the three ways, right? So if you find the exact match of the base word in the dictionary, then you can retrieve the information. So what kind of information you will retrieve here? Like parts of speech, or meaning of the sentence, or structure of the word. So if you find exact match of the word in the dictionary, just retrieve those information. So the parts of speech, or meaning of the sentence, or structure of the word. So you have to retrieve. And the second version is, suppose you find more matching patterns. Suppose you find more matching patterns. So that time what we will do? We will get confused, right? So the beauty means so many matches you found for that your base word, means we will get confused. So that time what we need to do? We need to combine this dictionary lookup model with another model to analyze the structure of a word. So this will become the hybrid model. Okay, so this is the second way. Then third way, suppose you did not find anything, any common pattern or common match in the dictionary. So that time also what we will do? You will combine with another model and make a hybrid model to analyze the particular word in the dictionary. So by using these procedure, we can analyze the structure of the word in the dictionary lookup morphological model. So see here, I wrote the sentences very clearly. Suppose if you find more matches in the dictionary lookup model will combine with other model to analyze the structure of a word. Suppose, see another chance, right? Here I explained, right, that one. Suppose if you may not found any matches, suppose means you did not found any matches of the base word. So this time also the dictionary lookup model will combined with other models to analyze the structure of the word. Okay, so this is about your dictionary lookup model. So hope everyone will understand this dictionary lookup model, right? So this is about your dictionary lookup model. Then we will go for the second model, that is finite state morphology. The second model is finite state morphology. So the finite state morphology is, yeah, this one. The second one is finite state morphology. Okay, so we'll go for that morphology, finite state morphology. Yes, so this one, finite state morphology. So before going to explain about the finite state morphology, we need to understand automata theory. So that I think everyone remember, if you are a BTech students, you will remember that flat and ATCD subjects. So automata theory and automata theory, this, so finite state automata theory and compiler design, like this, these two subjects you people will remember. So here we will follow the concepts of flat and automata theory concepts. So what are the concepts we will follow here? So in finite state automata theory we are having a 5 important states. So input must and should, and output also we need, and we are having the two states, that is starting state and ending state, and transitions. So starting state can be represented with a single circle, and ending state will represent with a double circle. So if you remember these flat and automata theory, then this finite state morphology will understand very easily and very clearly. Okay, so now we'll go for finite state morphology. So finite state morphology, so this is also used to analyze the structure of the word. So here, based on the states, based on the finite state, we will analyze the structure of the word. And totally this finite state transitions will be depending on suffix of the base word, prefix of the base word. So based on this suffixes and affixes, we have to analyze the structure of the word. Okay, so here, based on the finite state automata and formal language theory, this one, formal language theory, this morphological finite state model will work. So here the important thing in the finite state morphology model, this is especially used for the generation and recognition of the NLP tasks. Generation and recognition of the NLP tasks. Okay, then we'll jump into a simple example. See here, example will consider that grace. Grace is a simple example. We'll consider this is a one word. So this word we don't have a prefix and we don't have a suffix. So here this grace itself we can call it as a stem word or root word. Okay, by following the finite state automata theory, we have to draw the graph. So here grace, Q naught stem, starting of the input state is Q0, ending of the output state is Q1. So the stem word here it is grace. The output for this picture is grace. Suppose we added prefix. We added prefix for the grace, that is disgrace. So here prefix. So starting of the state is this one, input we are giving grace, and Q1 is the state, and stem is the root word, and Q2 is the output state. So the output here we will get is disgrace. The output we will get here is disgrace. So after that we added suffix also. So suffix is full. So the prefix and stem and suffix. So the output for this states, input state, prefix state, stem and suffix is disgrace full. So this is the output of this diagram. So totally here disgraceful, how we will draw the automata theory for disgraceful. So this is input, here it is a input, and the prefix and epsilon. Epsilon means, I think everyone knows that it is a null value. So it is a null value. And for the total here we are having a two end states. One word is disgrace, right? And one word is disgrace. here one ending state, and another word is disgraceful. So another ending word is disgraceful with the suffix one ending state, with prefix and stem one ending state. So this is the total what it is called finite theory, automata theory, diagrammatical representation of the given input word, that is disgraceful. So from this total finite state automata, here we'll have a two end states. So how we will calculate for the words grace? Epsilon plus stem, so that is equal to grace. Stem is what? Stem means what? Root word, right? So the root word or base word is, we are having grace. So this is this one. Then disgraceful, epsilon plus suffix plus grace. So this is disgrace. Suffix is dis and grace is the root word, that is stem word. Same like that, disgraceful. So disgraceful, epsilon suffix plus grace plus prefix. This one is epsilon plus prefix here, epsilon prefix, grace and suffix. So that is disgraceful. So this is the complete word for the total automata theory of given sentence. This one, like this, we have to sent. So minute, I'm making this is very small. Okay, so now we will go for the generation and recognition. So I said, right, so this finite state automata theory mostly used to generate the new words and recognize the root words. So what is the concept of generation? It means nothing but when we ever will give a word as a input, it will give output as a new words. It will generate the new words. So how it will generate the new words? By adding the suffixes or prefixes, we will generate the new word. So this concept is called as a generation. Then recognition. So whatever the thing you will give, whatever the word you will give as a input, it will give output as a root word. So that means here we are recognizing this is nothing but a root word, base word. So that is the concept of recognition. So this is about the finite state automata theory of your morphological model. So next, unification-based morphology. So we will discuss unification-based morphology, functional morphology, morphology induction in the next video. Hope everyone will understand these concepts, right? Thank you so much. Support me. Thank you very much. Please do subscribe my channel. This is Teju signing off. Thank you so much.